How to install the frame in storefront framing systems. Welcome to Building Knowledge 101. Watch our experts as they explain how to install aluminum storefront framing systems efficiently and effectively. Now, I mentioned that storefronts are set within the structure of the building, within the plane of the building. So you can see here, the wall around the storefront is proud of the storefront elevation. It projects out. So the storefront system is set within the plane of the wall. And then consequently, our attachment then is going to be around the perimeter. So you can see in this long elevation here, our anchors are going to be through the sill and through the head into the surround condition around it. So we're attaching through the frames into the surround condition around it. Now, when your glass subcontractor gets to the project site, initially he's going to inspect the elevation because his goal is to install the frames plumb, level, and true. We reinforce that all the time with subcontractors, is that's your goal, plumb, level, and true. So consequently, when they get to the job site, they need to inspect the openings and make sure those openings are good. Before we start anything, look at the openings and make sure that they're good, that the slab is straight, that it's the right depth, the walls are straight, that it's a good condition, because if we start with a bad opening, any amount of good frames, any good frame is not going to fix a bad opening. So before we start anything, let's start with a rough opening, look at it, and make sure that it's good quality and is constructible. So here's a section cut through your typical storefront system. So let's now start talking about how we're going to install the system. First thing we want to do is we want to make sure there's sufficient structure around the frame. Since we're anchoring around the perimeter, we want to make sure that the surround condition is structural and will hold the frames in place. We've run into situations where there's been insulation or an air cavity around the frame, so we don't have anything to anchor into. We want to make sure that there's sufficient structure around the frames. Second of all, when the frames go into the opening, we need to shim all the way around them. The shims need to be the full depth of the frames to support them all the way from the front to the back. Because when you start tightening down your fasteners around the perimeter, if it's not fully supported, the frame will start to twist a little bit. Now we're going to run a perimeter seal around the perimeter, and our recommendation is that seal be no less than 3/8 of an inch. It can be a little bit greater, but we're going to want to have it less than 3/8 of an inch. That's your dry line. That's going to run continuously around the elevation. Now, in some cases, if you don't have good structure around where your attachments are, here's an illustration of a strap anchor. Strap anchor is going to lock into the perimeter of the frames with a leg extending to the interior, providing for an attachment to the interior behind the frames. So that allows you to move your anchor point back to the interior where a structure is to get a better attachment. So now the frame is in, we're setting the frame in, we've got to anchor the sill to the subsill flashing. So your sill member has two components. There's the subsill flashing, which is this lower area here, and then the sill member, which is here, set down into the subsill flashing. So we need to anchor that down. So the detail you see here circled is a fastener, which is running through the sill into a raceway in the subsill flashing. Because once the subsill flashing is in place, anchored, and sealed, we don't want to penetrate through it because it's a wet area. Water is going to be accumulating in the subsill flashing, so we don't want to penetrate through it again. So this attachment method secures the sill to the subsill by running a fastener into the raceway and not having to penetrate through the weather barrier. Here's another option. This shows a clip snapped into the sill that allows an engagement, a roll-in locking engagement between the sill and the subsill. With this type of attachment, you're not using the fastener. The clip itself rolls in and gives an attachment and engagement, locking the sill down. The leg here on the interior is your water dam. The height of the water dam is really going to drive the water performance. The higher the water dam, the more negative pressure it's going to take to pull water up and over the water dam. So that drives your water performance. Between the back of the sill and the upturned water dam, you want to have a seal. A seal is required there. So either going to be a pre-installed gasket or the subcontractor is going to run a bead of sealant across the top of that leg. So when the sill member is set down, you seal between the water dam, the top of it, and the sill member, and that's going to drive your water performance. So if you've ever seen an attachment like this, where someone ran a fastener through the back of the water dam into a vertical to anchor the sill into the subsill flashing, think about the impact that's going to have now on your air and water performance. You penetrated through the water dam and you've effectively dropped the water performance. by putting a hole below the top of it. You've also damaged the air performance. So again, here's another view through a section cut of a storefront system. We're anchoring around the frames, and it's a hard fastener, a hard attachment. We've got shims around it. So if the architect anticipates deflection, we need to have some way of building in deflection in this type of attachment. That's where your receptor is going to come in. With a receptor, instead of the head of the storefront system being hard fastened to the surround, we're going to hard fasten the receptor to the surround, and then the storefront system floats inside of the receptor. So as the slab above deflects up or down, it simply slides the receptor up and down alongside the head of the storefront system, leaving the storefront dead loaded to the sill and the receptor taking up deflection. You could use a receptor around a jamb also. If you're anticipating side-to-side movement, a jamb receptor could be used. Also, if the opening is not perfectly straight, you can use a jamb receptor to hide and take up any intolerance in the vertical jamb. So let's talk about the building envelope. Since we're putting a storefront system into the exterior wall of a building, and we're punching a hole through the wall and inserting glass and glazing into it. So you've got three critical barriers in your building envelope, and now those barriers have to be taken over by your storefront system. So the first barrier is your dry line. All storefront systems have a continuous perimeter seal around them that has to be in the same plane all the way around the framing system. That forms the dry line in the system. The other critical barrier is the thermal line. So you can see here, this system is completely thermally broken through the head, the sill, the subsill flashing. That lines up with the insulating glass unit to give you complete thermal break through the system. So that's your thermal line. Last is your air barrier. Your gaskets are the primary component of the air barrier. They're installed in the frames under compression, so they're pressing against the glass, giving you a tight seal, and that's going to drive your air performance. And again, we pointed out the seal on the back of the water dam on the interior. That is all part of the dry line. So now we're looking at the thermal line. I want to show you a detail that I've seen a couple of times pop up, and that is a storefront system sitting on top of bright metal flashing. You can see in this detail the bright metal flashing is drawn running underneath the storefront system and turning up the backside of the water dam. The intent here, the thought is that if water gets out of the storefront system, we're going to have flashing underneath it as a secondary backup of protection against water. But what I want you to realize is that by doing this now, you bridge the thermal break. By running bright metal under the frames like this, you're bypassing the thermal break in the system, and this could lead to condensation on the interior because you bridge the thermal break. The other thing to stop and think about is if you follow through with a detail like this, the bright metal flashing would be set in the opening before the storefront. So when the storefront's installed, it's going to penetrate through the bright metal flashing, really nullifying any attempt of it to catch any water. And there shouldn't be any water leaking out of the storefront system to begin with, but by penetrating through the flashing to install the storefront, you've prevented it from being able to catch and hold any water. So with storefront systems, you've got a couple of different options for installing them. Here you can see the glass stop is on the exterior. So this is an outside glaze system, where here the glass stop is on the inside. So this is an inside glaze system. So from the architect's point of view, this is going to have no impact on your air thermal structural performance. It's not going to have any impact on the aesthetics. It's simply to ease and facilitate the glazing subcontractor installing the glass in the frames. In some cases, it might be easier for him to approach the frames from the exterior, where in other cases it might be easier to approach from the interior. So that's strictly for the ease and facilitation of installing the system. It doesn't have any impact on the performance or the aesthetics. Now let's talk a little bit about thermal performance. Take a look at this picture. I really like this picture because it shows the challenge that architects have with designing buildings today. This picture was taken in Colorado Springs. And if you look on the exterior, there's a barren tree, nice, beautiful winter sky in the background, snow on the ground. The only thing on the exterior is a bronze statue of a man sitting on a park bench. But then look on the interior. Look how warm and soft and comfortable and inviting it is. So you've got two extreme different environments, a conditioned interior space and a harsh, unconditioned exterior space. And the thing that's standing between those and separating those is the glass and glazing. So that's a lot of challenge on the glass and glazing system to protect that interior conditioned space from the harsh exterior conditioned. So let's talk a little about thermally broken systems. You have a couple of different options. This is a non-thermal system. You can see there's metal running all the way through from the interior to the exterior. So this is non-thermal. Now, kind of stepping up from that is what we call thermally improved. And AMA says any thermal break that's less than 0.21 of an inch is thermally improved. When you get into a thermal break that's greater than 0.21, now you're looking at a thermally broken system. So keep that in mind when you're looking at the environmental conditions. Can you get away with a non-thermal system, thermally improved or thermally broken? So check the energy codes to make sure that you're using the correct system, because there are 3 levels of thermal performance in most storefront systems. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.